All right, hello everyone. My name is Harris, and in this video we're going to go over number one of our final exam. Um, number one says given t of n equals 5t of n over 2 plus n squared, find out its asymptotic type bound using the master theorem. So starting out, like I said, we were given t of n equals 5t n over 2 plus n squared. So first we're just going to grab a, which is equal to 5, and b, which is equal to 2, and f of n, which we see that is equal to n squared. We take that a and b and we plug it into log b of a. And since b is 2, we just have log 5, which is 2.32. Based on the master theorem, we see that n to the 2.32 is greater than f of n, or n squared, which tells us to use case 1, where log 5 minus epsilon is equal to 2. So f of n equals big O of n log 5 minus epsilon, for epsilon is greater than 0, which tells us that the asymptotic type bound is a big theta of n log 5. I just want to mention that I did write this problem out. I tried to be clear as I was writing it out, so it seems like I might have wrote a lot just to explain that, but I kind of did that for every question. I'm just trying to make sure I explain kind of every single part, just in case Dr. Chen does not have time to watch these videos. He'll at least kind of see the way I tried to explain it throughout the videos. So on number 5, we have proved the previous asymptotic type bound using either substitution or induction methods. So the first step of the For the first step of the substitution process, we'll guess that the solution is the same from part A, which is big theta of n log 5. So secondly, we're going to prove that t of n equals cn log 5. So I'll just kind of restate the problem first, which is t of n equals 5t n over 2 plus n squared. So first we have t of n is less than or equal to 5c n over 2 log 5 plus n squared. And we plug it in, and we have t of n is less than or equal to 5c over 2 log 5 times n log 5 plus n squared. So I just want to point out that 2 of log 5 equals 5. That way you see on the next problem we kind of cancel out 5 over 5. I just want to point that out. And then we have a running equal sign. So we have c of n, or cn, excuse me, log 5 plus n squared. So we're going to let c equals 1, which then we have n log 5 plus n squared, which is greater than or equal to t of n equals t of n equals theta n log 5, which proves case 1 of the master theorem. And that is it for question 1. Thanks everyone for listening.